Hello everyone, welcome back to the Legoneers YouTube channel. Today I'm going to walk you through this circuit that we've designed as a team for an underwater ROV or a remotely operated vehicle. This setup is perfect for a variety of reasons. The main one being simulating how real underwater thrusters and control systems work, and another sub one being creating a smaller recreation of these motors just to understand how these work and also empower the future of human exploration of marine life without destroying or damaging any marine ecological ecosystems. So let's break it down. At the heart of this circuit, as you can see over here, is an Arduino Uno. This is the brain that controls the entire system. It's powered through a USB cable, but the motors get their power from a separate 9-volt battery to ensure that they have enough current without overloading the Arduino. Remember, in order to promote sustainability and renewable energy sources, we have gone for a rechargeable battery. It is shaped like a 9-volt battery, as that is the most common name used, but it's actually rechargeable, using an external power source, typically a USB hub or your own gadget device. Now let's talk about the motors. These DC motors represent our underwater thrusters. We're using two DC motors combined with a little bit of stepper power, because these are brushed motors, controlled by an L293D motor driver IC. This allows the Arduino to control both the direction and the speed of the motors. The IC is essential because it acts like a bridge, because some people call it an H bridge actually, between the low power Arduino signals and the high power required by the motors. To control the motors, we're using potentiometers here. These potentiometers basically represent joysticks. Ideally, we would use actual joysticks for a more realistic setup, but the Tinkercad's database didn't really have them, so we just relied on these potentiometers. By turning them, these potentiometers or the joystick, they send an analog signal to the Arduino. This then adjusts the motor speed and the direction based on the input. Remember, the input is the code that we give. The code will be discussed during the next coming videos. This simulates how you would control thrusters in a real ROV basically. Now let's check out the wiring, or the jumper cables actually. The potentiometers are connected to the analog pins A0 and A1 on the Arduino, sending variable voltage signals as you turn them, but for joysticks as you move them around. The L293D motor driver, the H-bridge, has inputs connected to pins 5, 6, 9, and 10, allowing the Arduino to send control signals to each motor independently and not both motors simultaneously. This is crucial when creating an underwater thruster, as we wouldn't want both motors spinning at the same direction or both motors spinning in opposite directions. And we would want them spinning in opposite directions actually. The 9-volt battery, which is actually a rechargeable battery for us, powers the motors directly since they require more current than the Arduino can supply. This reduces the chances of the entire circuit being fried or damaged. If a circuit's fried, you can't really use the wires anymore because they don't pass the current. They will still be in good form, but they won't just pass the current, so we'll have to resort to new equipment which will take new planning actually. The code behind this setup reads the analog values from the potentiometers and maps those values to control the motor speed and direction. As I said, we are making a separate tutorial on coding this Arduino IDE. This design is perfect for experimenting with underwater ROV concepts like precise maneuvering, so you need to precisely know where you are going, and thruster balance. Plus, it's also beginner friendly. So, as we've said, using Tinkercad to build these circuit models only if you're getting started with Arduino isn't a problem, because Tinkercad has many tutorials which we followed and external YouTube tutorials as well. This is particularly a new video that we've done describing our circuitry and probably the code in the next few videos, as we haven't really done this in any past innovation projects. While making this video, actually, we've learned a lot of stuff, including the schematics of this circuitry and how all of the components start moving as the circuit goes on, and a lot more, including MicroPython, Python coding, and circuitry modeling. Catch you in the next video.